Okay, May, June 2024, paper 3, variant 3. Question 1. A girl is cycling along a straight horizontal road. Figure 1.1 shows the directions of the forces acting on the cyclist as she cycles in the direction of force C. State which forces show the direction of the force due to gravity. Okay, that was easy. D. The force due to air resistance. If she's moving towards C, so the air resistance would be, yes, an A, exactly. Force A changes and becomes larger than C. If A is now larger than C, which is the air resistance is now greater than C. Actually, no, this is a wrong answer. She cannot, or she will not move backwards. No, that is wrong. She will slow down. Yes, thank you. The speed will decrease if the air resistance is greater than, okay, if the air resistance is greater than the forward force, then she will slow down, okay, slows down, or you can say the speed decreases or whatever. Another cyclist travels a distance of 250 meters in a time of 21 seconds. Calculate the average speed. How can I find the average speed? Average speed equals what? Total distance over total time. So the total distance is 250 meters and the total time is 21 seconds. 250 divided by 21. It would be around 12, I guess. 12 point something maybe. No. Okay, so 12 meters per second. That is the average speed. That was quite easy. Cyclist exerts a force of 36 newtons. Okay, 36 newtons to move the cycle forwards. Calculate the work done. Can I find the work done? Work done equals what? What is the unit of the, oh, what is the equation? Equation of the work done is force times, work done equals force times distance moved. Yes. The force is 36 newtons and the distance moved, distance traveled is 250 meters. So 36 times 250 meters is, and that's 36 times 250, which is 9,000. What is the unit? Work done is in energy, so joules. Exactly. Thank you. Excellent. Okay, next question. Does the distance have to be in meters? Yes, it does have to be in meters. For example, if the distance was in centimeters or kilometers or whatever, you have to convert it to meters. Yes. Question 2. We have a stop sign. And this is the front view and this is the side view. A strong wind blows and the sign begins to fall over. A man catches the sign before it completely falls over. Calculate the moment of the 5.6 Newton force about the pivot. So moment, basically, how can I find the moment? Moment equals, have to write down the equation. Force times, yes, perpendicular distance. Force times perpendicular distance. So 5.6 times perpendicular distance, which is 82. Should give you 459.2, which you could round up to 460 newtons dot centimeters. Okay. Moving on to the next question. The sign needs to be easy to move and stable. Needs to be easy to move and stable. The base cannot be fixed to the ground. You cannot fix the base to the ground. Suggest how to change the base so that the sign is more stable. How can I make this sign more stable? Bigger base, yes, bigger base. Lower center of mass. You cannot change the center of mass of the sign. Sadly, okay. Y- yeah. You can do two things. Do two things. Yes, you can lower the base a little bit. Okay, but how can you lower the base? Oh, how can you lower the center of mass? That's the question. How can I lower the center of the mass? By increasing the weight of the base. If you think about it this way, by increasing the weight of the base itself, you are now making it more stable by lowering the center of the mass. By lowering the center of the mass. So if I increase the mass of the base, that's the solution. Suggestion: increase the mass of the base. Increase the mass of the base. The explanation, it would be by if you increase the mass of the base, you're now lowering the center of mass. You're now lowering the center, okay, of mass. You would want to say, can I increase the area of the base? You might think about that. It would be a rather good answer, but is there an easy way to actually increase the area of this space? Well, خلاص, it's a sign. It's already set. Okay, it's already built. They already built the sign. There is no easy way of actually increasing the area of the base. That's the problem. Okay, there is no easy way. The easier way would be to increase. How would you increase the mass? By, for example, getting a bucket full of cement or something, or full of sand or whatever, and just putting it on the base. That would increase the mass of the base. Okay. Okay, yeah, moving on. There was a question, to round the answer. Yes, you have to round the answer. The answer was 459.2. That's too many significant figures. So we can round it to two significant figures. 460 is two significant figures. So that would be much better than writing 459.2. Okay, question three. State the energy stored for the water behind the dam. What is the energy stored for the water behind the dam? Yes, definitely it is gravitational potential energy. Okay, gravitational potential energy. Do not write it down as GPE, please write it down as gravitational potential energy. In the list of equipment, draw a ring around each item that a hydroelectric power station requires. Does it require a boiler? I don't think so. Does it require a cooling tower? Again, no. A generator? Definitely yes. Solar cell? Nope. And a turbine? Yes. State the type of transformer shown in 3.1. The type of transformer. The transformer right before the homes and factories. Is it a step up or step down? Yes, it is a step down transformer. Step down transformer. Why? Because in the cables, it have very high voltages. So we're talking the hundreds of thousands of voltages, which are very, very dangerous to us humans. If for example, 100,000 or 1 million volts enters our homes, we will probably be electrocuted. And we want to avoid that. I think so. Give two reasons why the power station uses high voltages. Yes. Why do we use high voltages? To reduce the energy lost. Okay, how do we reduce the energy lost? How can I reduce the energy lost? By decreasing the current? Yes. No, not easier transport. No, it's not about easing the transport. No, no. Decrease. Okay, decreasing the current. When you decrease the current, you actually decrease or reduce the energy lost. You can also say decreasing the power lost due to heating effect. You can also say that we can use thinner lines. They are all correct answers. Okay. More energy produced? No, that is wrong. More energy produced is wrong. C. Hydroelectric power stations may replace coal-fired power stations. State two advantages and two disadvantages. Um, Two advantages and two disadvantages of using hydroelectric power stations compared with coal-fired power stations. Do not include buildings. Oh, anyway, we want two advantages and two disadvantages. Hydroelectric may replace coal-fired. Okay, so we want two advantages of using these hydroelectric. First of all, we have to say that they are renewable. Yes, they are renewable. Well, we can also say what? We can also say no air pollution. No air pollution. Someone is saying, is voltage directly proportional to current? Um, when talking about the power in the transformers, actually the voltage and the current are inversely proportional. Power in the transformers, if you think about power equals VI, if I increase the voltage, the current will decrease inversely proportional. Anyway, disadvantages. What are some of the disadvantages of the hydroelectric power stations compared to coal-fired power stations? Okay, you damage the animal habitats. Yes. What else? Yes, it can flood the land behind it. Yes. Okay. Not many places that we can build it. Okay. Uh, okay. Yeah. Let's write them down. So first of all, it can damage. Okay. Damage animal habitat. Hmm. It can cause flooding behind. Okay. Behind the dam. Good. No, they are both reliable. The coal-fired power station and the hydroelectric power stations, they are both reliable. Describe the motion of the particles in a solid. In a solid. They vibrate in fixed place. In fixed place. Can I say reliable in the advantages if we were talking about, for example, if you wanted to compare the hydroelectric power station to the wind turbines, for example, or the solar cells? But when we compare them both, the hydroelectric and the coal-fired power stations, they are both reliable. So it's not an advantage over the other. No. Hmm. On figure 4.2, draw at least 10 particles to show the gases. Okay, 10 particles to show gases, 10 very far away. Okay, 4, 5, 6, 7, 8, 9, and let's say 10. Okay, far away. Describe the motion of the gas particles. They move fast and random, in all directions. Fast and random in all directions. At the beginning of the lesson, they had a shallow dish. Okay, figure 4.3 shows the mass at the beginning of the lesson. 4.4 shows the mass at the end of the lesson. The process, definitely evaporation. Describe the process that decreases the mass of the water in the shallow dish. Use ideas. We need to describe evaporation. So basically, you would say that the most energetic molecules escape from where? Escape from the surface. Okay, leaving behind the least energetic molecules. But for this question, we do not need to say that they leave behind the least energetic molecules. If they say, or if the question is asking why does it get colder, we might say that part. We have an arrangement for heating water. The hot water is stored inside the metal container. So this is the flow of the hot water, okay, and this is the flow of the cold water. Explain why the hot water is available at the top of the container. Use ideas about density. Why is hot water available only at the top of the container? Huh. Why is it? Because of the hmm, convection. Yes, because of convection. So basically, we need to explain what happens in convection. In convection, as hot water or as water heats up, hmm, as water gains kinetic energy and thermal energy, kinetic energy and thermal energy. The volume increases, and therefore the density. We have to talk about the density. Decreases, so the hot water moves up. That's why. That's why the hot water is always at the top of this container. Hmm. The electric heater is switched on for 1 hour every morning. State the name of the process that transfers thermal energy through the walls. Through the walls. Yes, definitely. Conduction. Through the walls is not radiation, it's conduction. State one way of keeping the water hot after switching the heater off. After I switch it off, how can I keep the water inside the container hot? By using what? Using an insulator. Using an insulator. Coloring the surface shiny white would definitely help, but it's not the most effective way. The most effective way is by using an insulation, or if it had an open surface, we would have needed to cover this surface. Okay, using a vacuum. Well, you can use a vacuum room, but again, you need to still cover it. Okay, you still need to cover it using a good insulator. Hmm. State the name of the type of wave which the direction of vibration is at right angles to the direction of travel. Right angles, perpendicular. Which of these waves, we had two types of waves, which of them moved perpendicularly to the transverse? Yes, thank you. The transverse. Okay, transverse. Excellent. Teacher uses a ripple tank to demonstrate a wave property. This wave tank. Complete the sentence about the wave property demonstrated in 6.1. This is diffraction. Yes, thank you. It is diffraction. Finally, yes. Uh, in a different ripple tank, the wavelength is 5.1 centimeters. The speed of the wave is 42 centimeters per second. Can I find the frequency? Yes, I can find the frequency. Speed equals what? Wavelength times frequency. Oh, I'm sorry, I skipped II. I skipped II. Thank you. On figure 6.1, indicate one wavelength. What is one wavelength? One wavelength is the distance between two wave fronts, the distance between two wavefronts. So this is W. Okay. Again, you can say the distance from this wavelength to this wavelength. This is W. Okay. Any one of these straight lines is called a wave front. So this is a wave front. This is a wave front. These are all wave fronts. The distance between two wave fronts is called the wavelength. Wavelength. Okay, so just write down W between two wave fronts. Okay. Hmm. Frequency. Can I find frequency? Yes, I can find the frequency. It would be the speed over the wavelength. Frequency equals speed over wavelength. The speed is 42 and the wavelength is 5.1, which would be around 8. Hmm, Around 8.2 hertz. 8.2 hertz. Yeah. If you want to write down the magic triangle, so the speed would be here, and then the wavelength and the frequency. So frequency equals speed over wavelength. Okay. Figure 7.1 shows a ray of red light incident at point P. On figure 7.1, draw the normal at point P. Okay, can I draw the normal? Yes, I can draw the normal. Using my ruler, I need to make sure that the normal is 90 degrees. Okay, the normal has to be exactly 90 degrees. So I'm drawing a normal at point P. I draw the path of the ray through the glass and into the air. Okay, so through the glass, what will happen to the ray? It will refract. Okay, and then again, in this prism or in this question, no dispersion will happen. No dispersion will happen. So you won't draw the seven colors. You will not draw red, orange, yellow. No, you'll only draw the red light. Why? Because this is only red light. This is only red light. It's a laser beam, okay, going into the prism. So it will only refract. Like, the question is, will it go closer? Will it bend closer to the normal or further away from the normal? Definitely closer to the normal. Why? Hmm, Because this is going into a more dense medium. Light is going into a more dense medium. So the speed will decrease and it will refract. It will bend this way, for example. Okay, again, you are using your rulers. Please, it will bend towards the normal this way, for example. And at this point, we can draw another normal and it will bend away from the normal downwards in this way. Okay, a ray of blue light replaces the ray of red light. The angle of incidence for the blue ray entering the prism is the same as in a 7.1. Describe any differences between the path of the blue and the red rays. How can I differentiate, or what will happen? What will the difference be between the blue light and the red light? You can say that the blue light will refract more. Okay, the blue light will refract more. Why will it refract more? Because it has a higher frequency. Okay, it will refract more. The blue ray refracts more. Another ray enters the glass prism and is totally internally reflected. State two conditions for a ray to be totally internally reflected. We need two conditions for total internal reflection. Total internal reflection. Hmm. Okay, critical angle. What about the critical angle? You can't just say this is not a it exceeds. Okay, so the angle of incidence is more than the critical angle. Yes, above the critical. Yes, the angle of incidence is more than the critical angle. Than the critical angle. Okay, what else? Critical angle. There's another very, very important condition for total internal reflection you sometimes forget about, but I've always said it. Whenever, yes, thank you, it has to be in glass. It has to be in a more dense medium. Okay? It has to be in a more dense medium. So for this example, it has to be moving from the glass to the air. It has to be going, okay? Okay? Going from glass to air. Okay? Going from glass to air. يلا. Figure 8.1 shows a part of the circuit for measuring the resistance of the lamp. We have a lamp, we have a battery and a meter. Okay, draw um, or show how to connect the voltmeter to measure the potential difference across the lamp. Okay, can I say going from higher to lower dense medium? Yes, you can say that. You can say that. Okay. Hmm. For this question, can I draw the voltmeter? Yes, I can draw the voltmeter. It has to be parallel to the lamp. Please draw it parallel to the lamp. Hmm, do not draw it parallel to the meter, because I've seen this way too much. Okay, I've seen way too many silly mistakes of people drawing the voltmeter parallel to the meter, which is nonsense. Okay, parallel to the lamp. The current in the lamp is 0.41 and the potential difference is 12. Can I find the resistance? Okay, I can find the resistance. R equals R equals V over I. 12 over 0.41. 29.2. Yes, 29.2, or you can just write it down as 29 ohms. Calculate the electrical power. Power. Yeah, what is the power? Uh, How can I, what's the equation? Power equals, we said it, power equals VI. خلاص, we need to memorize this equation. I know we haven't used it that much. Why? Because it's new to the syllabus. Kind of relatively new. So power equals VI, it's a relatively new equation. We have to memorize it. Power equals VI, the voltage times the current. We have the voltage 12 and we have the current 0.41. We have them. So 12 times 0.41, which would be 4.9 or 5. Okay, 4.9. What is the unit? What is the unit? Joules. Is it joules? Power is what? Watts. Is what? What? Ah, watts. Thank you. Okay, excellent. Hmm. Figure 9.1 shows three devices, a compass, a transformer, and an electromagnet. Hmm. Uh, Power, yes, power. You have another equation for the power. If you have mechanical power, if someone is doing some work or someone is lifting objects or something, yes, you can find the power of this man. So it would be work done over time. So you have two equations for the power, which are both correct. It depends on the situation, depends on the question you are solving. If you are solving a question requiring you to find the mechanical power done, so it's work done over time or energy over time. But for this question, you need to find the electrical power, which would be voltage times the current. Okay? Hmm. Each metal can be used once, more than once, or not at all. The compass needle. Which metal should we use in a compass needle? Compass needle. We need to use which metal? Definitely steel. Yes, thank you. Steel. What about the transformer core? Iron. Hmm. Transformer coils. Copper. Yes. What about the electromagnet? The core of the electromagnet. Core of the electromagnet is, yes, again, iron or soft iron. Okay, he has written down soft iron, so I will write down as well soft iron. VIT is the energy, the electrical energy. VIT is the electrical energy. The primary coil of a transformer is connected to a main supply of 220 volts. The primary coil has 1500 and the secondary has 650. Can I find the output voltage? Yes. VP over MP equals VS over NS. What is VP? Voltage, the primary voltage, 220 over NP, which is 1500, equals Vs over Ns, which is 650, cross multiply 220 times 650 divided by 1500. This would give you a voltage of, output voltage of 95 volts. Okay, really good. Point 3, we can ignore the point 3. Question 10. We have proctanium, Pa 23491. State the number of protons. 91. State the number of nucleons. What is the number of nucleons? Nucleons 234. Yes, thank you. The mass number. Nucleons is the mass number. Three forms of elements of proctanium: 234, 230, and 233. Different forms. What is the name given to these different forms? Isotopes. Yes, isotopes. Hmm. A teacher demonstrates radioactive decay by using a sample of Proctanium-234. The sample emits beta particles. State the nature of these beta particles. The beta particles are electrons. Yes, thank you. They are electrons. You can say negative electrons. Yes. Okay, you can say negative electrons, but we need to write down electrons. If he asks about the charge, you'd say negative. Yes. The teacher obtains data for the decay curve. You have the count rate, and then he's asking to find the half-life. How can I find the half-life? Clearly show you're working on the graph. Okay, clearly show you're working on the graph. CI, it would be electrons. Okay, electrons. How can I show the working on the graph? How can I find the half-life? First of all, you have to take the first number, which is 900, hmm, divided by 2, which is 450. On the graph, you have to draw a line from 450 until you reach this point, and then you have to draw another line, a vertical line, which reaches exactly, okay, which is exactly at the 70-second mark. It's exactly at the 70-second mark. Okay, please be very meticulous while drawing this line. Hmm. Okay, suggest a reason. It's 70 seconds. This is the half-life of Proctanium 234. Suggest a reason why the half-life makes it suitable for this demonstration in the lesson. Okay, we're in class in a laboratory, for example. Why is it suitable for use in this laboratory? Because it is fast. Okay, because it has a very short half-life. Yes, that would be a better answer because it has a very short half-life. Hmm. Has a very short half-life. Okay, so it's not that dangerous. It's not that dangerous. Hmm. Yeah. Question 11. Solar system contains a number of objects. Write these objects in order of their size. So from the smallest to the largest. In our solar system, what would be the smallest of these objects? Yes, I think it would be the asteroids. And then, the moon, yes, the moon, our moon, and then planets, and then last but not least, the sun, the largest object in our solar system. In our solar system. Redshift is an increase in the observed wavelength of light emitted from distant galaxies. Observed wavelength from distant galaxies. State what redshift indicates about the movement of distant galaxies. So what have we learned from the redshift? What is redshift? Basically, the wavelength of the light emitted by the very distant galaxies is a bit longer. The wavelength is a bit longer. So what does this indicate? What have we learned? Okay, we got to the conclusion that the universe is expanding. Yes, okay. What does this indicate about these galaxies? That they are moving away. That they are moving away. Okay. Yes, a lot of you are saying that the universe is expanding, which is correct, but this is the answer for the second question. If you read the second question, state why redshift in the light from the distant galaxies supports the Big Bang theory. How does this support the Big Bang theory? Because the universe is expanding. Okay, universe is still expanding. It has been expanding for over 14.5 billion years. Okay, so that the universe is expanding. Okay, define one light year. What is one light year? One light year is it's not a time. Please do not say time. It is the distance traveled. It is a distance traveled by light in space or in vacuum for 1 year. Okay, distance traveled by light or in 1 year. Um, in 1 year. Big Bang. There's nothing. Anyway, scientists can send spacecraft to planets. There are many planets outside the solar system. So just one reason, other Then cost. Why scientists do not send spacecraft to planets outside the solar system? They will get lost. No, they will not get lost. Uh, Very far. Higher pressure. Actually, lower pressure, not higher pressure. Dangerous. Too far. Okay. Yes, too far. Definitely. This is the most suitable answer. Okay. The distances are huge. Distances are humongous. You can't even fathom the amount of distances are. We're talking about trillions of kilometers. We said the closest star to us, other than the sun, is 4 light years away, which is around roughly around 40 trillion kilometers. That's it. It's only 40 trillion kilometers. 40 million kilometers. That's the closest star. So yes, they are too far away. Okay, too far away. They're gonna die by the time it comes back. Generations will pass. Wow, wow. You have an excellent imagination. An electromagnetic wave travels from the sun to the earth in a time of 500 seconds. Okay, so this is basically sent from the sun. Yes, time taken to travel from the sun to the earth is 500 seconds. The speed is 3 times 10 to the power of 8. Can I find the distance? Can I find the distance? Yes, speed equals distance over time. Speed equals distance over time. So basically, distance equals speed times time. Okay, distance equals speed times time. So the speed is 3 times 10 to the power of 8, and the time is 500 seconds, which is okay. This would give you 1.5 times 10 to the power of 11. 1.5 times 10 to the power of 11. 150 billion meters or 150 million kilometers. 150 million kilometers is the distance between the Earth and the sun. Distance between the Earth and the sun. Okay.